In this video, we're going to look at some more examples of integration by parts. However, these examples are going to actually require a repeated application of integration by parts. So, the first example is the integral of x squared times sine x. So we need to choose one function to be our u and one function to be our v dash. Another way you can think of this is we need to pick one function to differentiate and one function to integrate. Now, we could go ahead and use the Lie-H rule, which tells us that we want to choose u to be x squared, so we want to differentiate x squared. But even without that rule, it should be obvious that we want to choose x squared to be differentiated because that will reduce the power of x, and then eventually that function will disappear and just become 1. If we chose x squared to be integrated, that's just going to become a higher and a higher power of x. So we're going to choose u to be x squared. Differentiating that will give us 2x. That means our v dash is going to be sine x, and integrating that is going to be minus cos x. Don't forget the minus there. A lot of people forget the minus. Okay, so now we can go ahead and use our integration by parts formula, which tells us that it's u times v, so minus x squared cos x minus the integral of u dash times v. So that's 2x and then times minus cos. Well, that minus can come out the front and make a plus here. And then we have the cos x dx. And as you can see, in this integral that's come out, we still have a product of functions which requires another application of integration by parts. So let's go ahead and do that. Again, we're going to choose the algebra, or the x, to be the thing that we're going to differentiate. And you can see now that it disappears. Maybe we'll call it 2x, and then it becomes 2. V dash is going to be cos x, and so v now is the integral of cos, which is sine x. So, what do we have? Well, we have minus x squared cos x. Now for this next integral, it's going to be u times v. So that's 2x times sine x minus the integral of u dash times v, which is 2 sine x. Now this integral, we can integrate that without actually using integration by parts. So we just go ahead and use our normal techniques. So we have minus x squared cos x plus 2x sine x minus the integral of sine x is a negative cos, so this becomes positive 2 cos x plus a constant. And that is our final answer. The next example is the integral of x times log of x all squared. So here we definitely need to choose log of x all squared to be the function that we differentiate, because probably don't know how to integrate that. So u is going to be log x all squared, and when we differentiate that, we bring the power down, we reduce the power by 1, so that's to the power 1 now, and we times by the inside derivative. The inside derivative of log x is 1 on x. Alright, and that means we're choosing x to be the function that we integrate, so v dash is x, which means that v is x squared on 2. Let's use our integration by parts formula. So it tells us u times v. So I'm going to write x squared on 2 first, times log of x squared, minus the integral of u dash times v. Now u dash is 2 log x times 1 on x, and v is x squared on 2. Alright, now before we try to choose our u and v dash for this integral, let's actually do a bit of cancelling. 2 divided 2 will cancel, and this x will cancel with 1x there. So what we're left with, well, we still have this bit at the front, but in our integral we're left with x times log x. And we need to do another application of integration by parts here. Again, we want to differentiate the log function. So u is going to be log x, and u dash is going to be 1 on x. V dash will be x which means v will be x squared on 2. Again, we apply our integration by parts formula. Let's move this up a little bit. So we still have this thing hanging out at the front, minus. Now, when you have a minus outside of an integral, it's a very good idea to put big brackets like this, because everything after this minus needs to have, the minus applies to everything after this bracket. But when we're doing integration by parts, it's very easy to forget one of those minuses. So that's why I always like to put a bracket out the front. So we have u times v, which is x squared on 2 times log x, minus the integral of u dash times v. So 1 on x times x squared on 2. Okay, we still have this bit out the front. Now we might as well go ahead and distribute this minus through these brackets. So we have minus x squared on 2 log x, and then plus this integral, because we have two minuses. Now this integral can simplify. We can divide by x here, and we just have x on 2 dx. And so our final answer is going to be x squared on 2 times log x all squared minus x squared on 2 times log x plus x squared on 4 plus c.